Okay, so before we go into some more exercises with this unit, this section, I want to kind of review the names and the relationships of the angles that are formed by parallel lines cut by a transversal. Okay, so the first kind are the ones that are congruent when lines are parallel. Okay, so remember, this relationship only exists when lines are parallel. So we have, first of all, we have corresponding angles. Corresponding angles are on the same side of the transversal, and one's interior and one's exterior. So pairs like that would be like 1 and 5, 4 and 8, 2 and 6, and 3 and 7. Remember, those are going to be congruent. The other types are alternate interior angles. Okay, and they're exactly what they sound like. They're on opposite sides of the transversal inside the two lines. So when they're congruent, when the lines are parallel, they're congruent, and that would be in this, according to this diagram, it's 4 and 6 and 3 and 5. The other type is alternate exterior. Okay, and again, those are on opposite sides of the transversal, but outside the parallel lines. So that's 2 and 8 and 1 and 7. Now the other types of angles that we have are supplementary, which means they add up to 180. Okay, and there's two types that we mainly use. Those are same side interior. So what does that mean? They're on the same side of the transversal inside the parallel lines. So that's angle 3 and 6 and angle 4 and 5. All right. What about same side exterior? Those are also supplementary. Same side of the transversal on the outside of the parallel line. So that's going to be 2 and 7 and 1 and 8. Okay, so as we go forward with this, after we've named our angles, we're going to use, and we know these relationships, we're going to use this knowledge to answer certain application problems. Okay, so one of these is we have all three of these guys right here are parallel. Okay, and when the lines are parallel, the relationship between the angles is either congruent or supplementary. So first of all, what I'm going to do is find all the angles that are congruent to this angle 9. And that's actually a lot easier than it seems. First of all, I look at angle 9 and I'm like, okay, that's that one. This one right here is a vertical angle to it. So those guys are congruent. From there, I can jump and find each corresponding angle from here. So these guys are all congruent to angle 9. So those are all 76 degrees. So if angle 9 is 76, angle 1 is 76, angle 3 is 76, angle 5, angle 7, we already know angle 9, and then angle 11. The others are the supplement to that, which means I take 180 degrees and subtract 76, and I get 104. So the rest of them are all 104 degrees. So one of the things to remember is if you have parallel lines, the relationships between the angles are either congruent or supplementary. So if they look like they're the same measure, you can usually assume they are the same measure, and if they don't, you can assume that they're supplementary. Not always safe to say, but when the lines are parallel, you can definitely do that. So first of all, let's look at this one right here. If these two angles, what is the relationship? Well, if I look right here, they're on the same side of the transversal. One's interior and one is exterior. So that is a corresponding angles. Now, if corresponding angles are there and the lines are congruent, I can assume the angles are, I'm sorry, and the lines are parallel, I can assume the angles are congruent. So when they're congruent, in order to solve for the variable, I set them equal to one another and solve for it. So I have 11x minus 5 is equal to 7x plus 27. So I'm going to bring the variable to one side. Okay, and I get 4x minus 5 is equal to 27. So I add 5 and I have 4x is equal to 32 divided by 4, and my x is equal to 8. Now in this next one, I can see that they're both on the same side of the transversal and they're both inside these two lines, so they're same side interior. So that means they are supplementary. So when lines are supplementary, when angles are supplementary, that means if I add them together, they equal 180 degrees. So what I do is, in order to solve for the variable, I add these two expressions together. And that's what I get. So I combine my like terms. So I have 9x plus 4x, that's 13x. And I have 3 minus 5, so that's minus 2. And that's equal to 180. So then I add to 13x equals 182. And if I divide both sides by 13, I get 14, I believe. Yep, x is equal to 14. Okay, now what if we have a problem like this where we have more than one to solve for? So let's take a look at this. Sorry, go back. So the first thing I'm going to do is find the one where I have the same variable. See how these guys have the same variable? They both have x. So then I'm going to ask myself, what is the relationship between those two lines? And they are those two angles. And those are alternate exterior, which means that they're going to be congruent. So I'm going to set 13x minus 27 equal to 10x plus 6. So I'm going to subtract 10x on each side. So that's 3x minus 27 is equal to 6. So I add 27. So I have 3x is equal to 33. And I divide and I get x equals to 11. So now I want to see what this angle measure is right here. So I do 10 times 11 plus 6. So that's 110 plus 6. So this is 116. So these two angles, if you can tell right here, are supplementary. They add up to 180. So if this is 116, this is going to be 64 degrees. So I set 9y plus 19, and I set that equal to 64. Okay, so I subtract 19, and I get 9y is equal to 45, and I divide by 9, so y is equal to 5. All right, so for this one right here, you need to determine whether or not these are supplementary or congruent. So let me show you a little clue here. If we're assuming these lines are parallel, now, and we're going to kind of assume that because we're going to say, okay, these lines are these angles are going to be equal or these angles are going to be either equal or supplementary. So if I look right here, all my angles with a blue dot are going to be supplementary. I'm sorry, are going to be congruent if all these lines are parallel. So if I look right here, if angle 3 is 107, what must angle 16 be? So notice how, see how they're the same color? Let me just do this. So if they're the same color, this is how I do this. I'm going to undo that for a second. Oh, mercy. If they're the same color, then I'm going to assume that they're congruent. And if they're not, if they're different colors, then I'm going to assume that they're supplementary. Okay? This is just a trick I've learned throughout the years. It helps me a lot. Okay? So if I have angle 3 is equal to 107, 3, and they said, what must angle 16 be? So if 3 and 16 are both red, so they're going to be the same measure. So it's going to be 107. 15 is 84. What must angle 14 be? Now see how these guys are two different colors? So I know they're going to be supplementary. So 180 minus 84 is 96. Okay, hopefully this helps you. And then we have angle 3 is congruent to angle 6. What converse is that? That proves those angles are congruent. Now remember, what type of angles are they? Those are alternate interior, so it's the converse of alternate interior angles. If angle 7 is congruent to angle 15, what converse proves that these two lines are parallel? Well, 7 and 15 would be corresponding angles, so that's the converse of corresponding. If angle 5 plus angle 9 are equal to 180, which means they're supplementary, what converse proves that those are same side interior angles, so that's the converse of same side interior. And I just do SSI. So, and then we have if 12 is congruent to 13, so we've got 12 and 13, those are alternate exterior angles, so that would be the converse of alternate exterior angles. Okay? All right. So now we're going to go into a little bit more about slope. We can use slope-intercept form, we can use rise over run, and we can use the slope formula. So remember, if you have a horizontal line, your slope is 0, and if you have a vertical line, your slope is undefined. All right? Now, the ordered pair slope formula is the difference in the y values divided by the difference in the x values. And then we have slope-intercept form, which is y equals mx plus b. Remember, m is always represented by the slope. And standard form, which is ax plus by equals c. Okay? Now moving on. The slope of parallel lines. So remember that parallel lines have the same slope. Let me just undo this. Hold on. There you go. And remember our symbol for parallel And perpendicular lines have slopes that are opposite reciprocals. Okay, which means opposite means you change the sign. Reciprocal means you flip the fraction. All right. Okay, sorry about that. So now your slope, to do this, we're going to use rise over run. So remember, we start at the leftmost point, and we're going to go either up or down, and here I'm going down. So I go down 1 and over 1, 2, 3, 4. So my slope is negative 1/4. Oh, shoot. Let me see this. Try this. Negative 1 divided by 4. Okay, so your parallel slope is exactly the same. So that's negative 1 over 4. Now the perpendicular slope is the opposite, which means we're going to make it positive, and the reciprocal. So the reciprocal of 1/4 is just 4 over 1, so it's just positive 4. Now here we can see how this line goes up and down, so my slope is undefined, right? The parallel slope would also be undefined, and the perpendicular slope would be 0. Remember, the only way that horizontal and vertical lines are perpendicular is if one's vertical and one is horizontal. Okay, so for these, we're going to determine whether or not these lines are parallel, perpendicular, or neither. So what I have to do is take the slope of each. Now I'm going to do some shortcuts with the slope formula, but I want you guys to pay attention, okay? So the first thing I'm going to do is y2, which is negative 12, minus 3, divided by 2 minus negative 4. So that's equal to negative 15 over 6. Now, to reduce this, it's going to be negative 5 over, I'm divide everything by 3, so it's negative 5 halves. So let's do the same thing for this other set of points. So it's 1 minus 5, and then I do 0 minus 10. So this is negative 4 over negative 10, and if I reduced it, that's equal to 2/5. Now, do you see how these are opposite reciprocals? Remember that if I multiplied these two slopes, these are perpendicular. If I multiply two perpendicular slopes, their product is going to be negative 1. So if you multiplied negative 5 halves times 2/5, you would get negative 10 over 10, which would give me negative 1. All right, so let's do this one right here. So for this one, the slope is negative 15, I'm sorry, minus 3 divided by 8 minus 2. So that's negative 18 over 6, which gives me negative 3. And then my next one is 11 minus 2 divided by negative 5 minus negative 2. So that ends up being a positive 2. So this is 9 over negative 3, which is also negative 3. So when they're exactly the same, they're parallel. Okay. Now, for these, let's go ahead and do these. We have 6 minus 6, which, remember, if your y values are the same, your slope's going to be 0. So let's just double check. This one is negative 1 minus 5. So that's 0 over negative 6, which is just 0. And then my other one is -4 minus -7, so that's +7, over -2 minus -2, which is +2. So I get 3 over 0, which is undefined. Now when we do that, my slopes are perpendicular because one's 0 and one's undefined. Now when you do these, you have to put these lines in slope-intercept form, or at least identify the slope in them, and the only way to do that really is to put them in slope-intercept form. So here, remember that when you do this, y equals mx plus b, m is the slope of the line. So here, when I have y is equal to 1x plus 6, my slope right here is 1. Let's look at this one. I have 1x minus 1y is equal to 2. Do you see how I'm putting in the ones? I'm doing that for the reason that I want to make sure that it makes it a little bit easier and prevents me from making any mistakes and not forgetting about that 1. So the first thing I do is subtract 1x from each side, and then I divide by the number in front of y. So I divide by -1. So this ends up being y is equal to 1x minus 2. So again, my slope is 1. So these are parallel lines. Here, I can see that my slope is -2. So let me just go ahead and put this in slope-intercept form. I'm going to subtract 1x from each side, and I get -2y is equal to -1x plus 8. And then I divide by -2. I've got y is equal to a positive 1/2 times x minus 4. Now, if I multiplied 1/2 times -2, so this is my slope is 1/2, I get -1. So these are perpendicular. Let's try this next one. I'm going to subtract 4x from each side, and I get 3y is equal to -4x plus 9. Divide by 3. So I get y is equal to -4/3 x plus 3. My slope is -4/3. Here, I'm going to subtract 3x, and I've got 4y is equal to -3x plus 36, and I divide by 4. So I get y is equal to -3/4 x plus 9. Now, since these are both negative, even though they're reciprocals of each other, they are not perpendicular because one has to be positive and one has to be negative. So this is neither. Now, whenever you have, remember I did a horizontal line has a 0 slope, and its equation is y equals to some number. So that's what we get here. So these are both slope is 0 for both of them. So they are parallel lines. You could always try to graph these in your calculator or in Desmos, and you'd be able to see that these are both parallel lines as well. Okay? All right, so that is about my time limit. So hopefully you guys can work on this quiz number 1. But that is my time limit for this section. This is the first section of the geometry review. So hopefully this helps you guys. Let me know if you need anything else. Have a great day.